Let us go to the next question. Oxidation number of potassium in K2O, K2O2 and KO2 respectively is. So the given compounds are K2O, K2O2, KO2. The first compound is potassium oxide. The next compound is potassium peroxide. And the last compound is called as potassium superoxide. In all these compounds, you have to find the oxidation number of potassium. So for the potassium atom, you have to find the oxidation number. But we already know that potassium is a group 1 element. So all the group 1 elements exhibit +1 oxidation state. Always all the group 1 elements exhibit either +1 oxidation state or in their elemental form, in their uncombined state, they exhibit 0 oxidation state. So in their uncombined state, they exhibit 0 oxidation state. Otherwise, in compounds, all the group 1 elements exhibit +1 oxidation state only. So in all the 3 compounds, the oxidation state of potassium is +1 only. So what is the difference in all these 3 compounds? Potassium oxide, potassium peroxide and potassium superoxide. What is the difference? The difference is the oxidation number of oxygen atoms. In all the 3 compounds, the oxidation number of oxygen atom is different. So we can find that. So in first compound K2O, let us find the oxidation state of oxygen. The oxidation state of potassium is +1 into 2 atoms are there, plus X equal to 0. 2 plus X equal to 0. The value of X is -2. Then potassium peroxide K2O2. So the oxidation state of potassium is +1 into 2 plus 2X equal to 0 because 2 oxygen atoms are there. So you have to write 2X. Then 2 plus 2X equal to 0. 2X is equal to -2. So the value of X is -1. Then the last compound, potassium superoxide. So +1 plus 2X equal to 0. 2X is equal to -1 and the value of X is -1/2. So in all these 3 compounds, the oxidation state of oxygen is different. In potassium oxide, it is -2. In potassium peroxide, it is -1. And in potassium superoxide, it is -1/2. But the oxidation state of potassium is the same. It is +1 only. So the oxidation state of potassium is +1. So the correct option is option B. The next question is the oxidation states of chromium in the given 3 compounds respectively are. So the first compound is CrH2O 6 times Cl3. 3 chlorine atoms are outside the coordination sphere. So 1 chlorine atom will have the charge of -1. 3 chlorine atoms will have the charge of -3. So the complex will have the charge of +3. So only the overall compound will be neutral. Chlorine atoms are having the charge -3. Therefore, the complex will have the charge of +3. Now let us find the oxidation state of chromium. So for the unknown element, the oxidation state is X plus H2O is given. Water molecule is a neutral ligand. So for the neutral ligand, the charge is 0 into 6 ligands are given. So everything equal to +3. So the value of X is +3. Let us go to the next compound. C6H6 twice is given. So let us find the oxidation state of chromium. X plus C6H6 is benzene. Benzene is also a neutral ligand. First we saw water molecule. Water molecule is also a neutral ligand. Benzene is also a neutral ligand. So the charge is 0 into 2 and the overall charge is also 0. So the value of x is also 0. So you can eliminate option A and option B because here for the B compound, for the second compound, 0 is not mentioned. Only for C and D, 0 is mentioned. So we are going to check between the options C and D only. The next compound is K2 Cr Cn twice O twice O2 NH3. So this compound is given. So outside the coordination sphere, potassium atom is given. So one potassium atom will have the charge of +1. Two potassium atoms will have the charge of +2. So outside the coordination sphere, the charge is +2. So this complex ion will have the charge of -2. So Cr Cn twice O twice O2 NH3 charge is -2. Now let us find the oxidation state of chromium. So for unknown element it is X plus cyanide ion is given. So for cyanide ion the charge is -1. -1 into 2 plus oxide ion is given. For oxide ion the charge is -2. -2 into 2 plus then O2 is given. So let me write here. For cyanide the charge is -1. For oxide also, for oxide the charge is 2 minus. Then the next one O2 is given. This is peroxide. For peroxide also the charge is 2 minus. So -2, only one unit is given. Then NH3. NH3 is a neutral ligand. So 0 and everything is equal to the charge -2. So X -2 -4 -2 equal to -2. So X -8 equal to -2 and the value of X is equal to -2 plus 8 will become +6. So the value of X is +6. So the correct option is +3, 0, +6. So the correct option is option C. Next question is, amongst the following, identify the species with an atom in +6 oxidation state. First option is MnO4-. Oxidation state of manganese, X plus oxygen atom will have the oxidation state of -2 into 4 equal to -1. X -8 equal to -1. X is equal to -1 plus 8. So the value of X is +7. So the first option is not correct. Cr Cn 6 times 3 minus X plus cyanide ion is having the charge -1 into 6 equal to the charge -3. X -6 equal to -3. X is equal to -3 plus 6, which is equal to +3. So option B is also not correct. Cr2O3. Let us find the oxidation state of chromium. 2X plus -2 into 3 equal to 0. So 2x minus 6 equal to 0. So I will continue here. 2x is equal to +6. So the value of x is +3. So option C is also not correct because in question they are asking the compound with an atom in +6 oxidation state. So obviously the correct option is option D only because the other three options are not correct. Let us check the oxidation state of chromium in option D. CrO2 Cl2. Already we have seen a question finding the oxidation state of chromium in chromyl chloride. So I will do it again. X plus -2 into 2 plus -1 into 2, everything equal to 0. So x -4 -2 equal to 0. So x -6 equal to 0 and the value of x is +6. So the species with an atom in +6 oxidation state, the correct option is option D. Next question is, oxidation state of sulfur in anions SO3 2-, S2O4 2-, and S2O6 2- increases in the orders. First, SO3 2- is given. Let us find the oxidation state of sulfur. X plus -2 into 3 equal to the charge -2. So x -6 equal to -2. So the value of x is, when you solve this, you will get x equal to +4. Let us find the oxidation state of the next compound. S2O4 2 minus. 2x plus minus 2 into 4 equal to, the charge is minus 2. 2x minus 8 equal to minus 2. 2x is equal to plus 6. So the value of x is equal to plus 3. Next compound is S2O6 2 minus. 2x minus plus minus 2 into 6 equal to minus 2. 2x minus 12 equal to minus 2. So 2x is equal to, when minus 12 goes to the other side, it will become plus 10. So the value of x is equal to plus 5. So 10 divided by 2 is plus 5. So when you arrange this in increasing order, first we have to write the plus 3 oxidation state. So S2O4 2 minus less than, then you have to write the plus 4 oxidation state, SO3 2 minus, then you have to write the plus 5 oxidation state, S2O6 2 minus. So the correct option is S2O4 2 minus less than SO3 2 minus less than S2O6 2 minus. So the correct option is option C. The next question is, in which of the following reactions hydrogen peroxide acts as an oxidizing agent? First, what is an oxidizing agent? An oxidizing agent oxidizes other substances but itself undergoes reduction. So here hydrogen peroxide should undergo reduction and the other substance present in the reaction medium should undergo oxidation. So we are going to check whether this is happening or not. So the first equation, let us take that HOCl plus H2O2 gives H3O plus Cl minus plus O2. So the other substance should undergo oxidation and hydrogen peroxide should undergo reduction. Now first let us check the other substance. First we will find the oxidation state of chlorine in the compound. The oxidation state of hydrogen is plus 1 and for oxygen it is minus 2. Then for the unknown element it is x and everything equal to 0. So minus 1 plus x equal to 0 and the value of x is plus 1. So the oxidation state of chlorine is plus 1. Then in the product chloride ion is present, Cl minus is present. So the oxidation state is the charge minus 1. So from plus 1 the oxidation state of chlorine has changed to minus 1. So this is decrease in oxidation state. And what is decrease in oxidation state? It is reduction. So the other substance has undergone reduction. So obviously hydrogen peroxide is acting as a reducing agent in this equation. It is not acting as a oxidizing agent. Now let us see the oxidation state change in hydrogen peroxide. So we know in hydrogen peroxide the oxidation state of oxygen is minus 1. Now if you see the product, elemental oxygen is present, dioxygen. So in its free state, the oxidation state of oxygen is 0. So from minus 1, it is increased to 0. So increase in oxidation state is oxidation. Hydrogen peroxide, the oxidation state changed for oxygen from minus 1 to 0, which is increase in oxidation state. So itself it undergone oxidation, but the rule is it should undergo reduction. So the first option is not correct. Let us go to the second option. The second option, I2 plus H2O2 plus 2OH minus gives 2I minus plus 2H2O plus O2. So let us see the other substance first. So in the free state, iodine has the oxidation state of 0. Then in the iodide ion, the charge is minus 1. So from 0, it is decreased to minus 1. So decrease in oxidation state is obviously reduction. So here also the other substance has undergone reduction. So in this case, hydrogen peroxide is again acting as a reducing agent. It is helping for the other substance to undergo reduction. So hydrogen peroxide is acting as a reducing agent. Let us check the products also. So the oxidation state of oxygen in hydrogen peroxide is -1. In product also, we are having dioxygen where the oxidation state of oxygen is 0. So from -1, it is increased to 0. So increase in oxidation state is oxidation. So this equation is also wrong. You may think that water molecule is also present. In water molecule, the oxidation state of oxygen is -2. So from -1 to -2, it is decrease only, no? So we can say hydrogen peroxide has decrease in oxidation state. So it has undergone reduction. We may think in that way, but you should not think in that way because here water molecule is present as a byproduct. So you may see OH minus is given. So the reaction happens in a basic medium. So in basic medium, in this reaction, when H plus is produced by the hydrogen peroxide, so it reacts with the OH minus and it leads to the formation of water molecule. So here you should not see the water molecule. Whenever dioxygen is present, obviously it is oxidation. Hydrogen peroxide is oxidized to O2. Next equation is 2MnO4 minus plus 3H2O2 gives 2MnO2 plus 3O2 plus 2H2O plus 2OH minus. So let us see the oxidation state of manganese in the reactant and product. So X minus oxidation state of oxygen is -2 into 4 atoms, everything equal to -1. X minus 8 equal to -1 and the value of X is +7. Already we have seen this. And in product side, X minus 2 into 2 equal to 0. X minus 4 equal to 0 and the value of X is +4. So here also from +7 to +4 is decrease in oxidation state. So the other substance has undergone reduction, and in this equation also hydrogen peroxide is acting as a reducing agent and not as oxidizing agent. So the oxidation state of oxygen is -1 in hydrogen peroxide. Then in product you are having dioxygen. So here the oxidation state is 0. So increase in oxidation state has happened. So it is oxidation. But what is the rule? The oxidizing agent should oxidize the other substance and itself should undergo reduction. But in all the three equations, here hydrogen peroxide acts as a reducing agent because in all the three equations, it undergoes oxidation only and not reduction. So the first three options are wrong. So obviously the correct option is option D. So let us check that. So option D is PbS plus 4H2O2 gives PbSO4 plus 4H2O. So in this equation, in product, O2 is not present. So directly we can tell the answer by seeing the product side itself. In the other three equations, O2 is present. So in other three equations, O2 is present. So it means hydrogen peroxide has undergone oxidation. But in this equation, O2 is not given. So let us see this reaction from the starting. So in lead sulfide, the oxidation state of sulfur is -2. And in lead sulfate, the oxidation state of sulfur is +6. So we can also find that the oxidation state of lead is +2 plus X, then -2 into 4 equal to 0. So 2 plus X minus 8 equal to 0. So the value of X is +6. So always you remember in sulfate ions, SO4 2 minus, the oxidation state of sulfur is always +6. So from -2 to +6 is increase in oxidation state. So increase in oxidation state is oxidation. So hydrogen peroxide oxidizes the other substance. So here it acts as a oxidizing agent. So only in option D it acts as oxidizing agent. Now let us see the oxidation state of oxygen. In hydrogen peroxide it is -1 and in water molecule it is -2. So -1 to -2 is decrease in oxidation state. Decrease in oxidation state. So it is reduction. So the rule is followed only in this equation. So only in option D, the other substance is oxidized and hydrogen peroxide is reduced. So the correct option is option D. The next question is, consider the reaction H2SO3 plus SN4 plus H2O gives SN2 plus HSO4 minus plus 3H plus. So in this question, you have to find which ion or which compound is acting as an oxidizing agent and what process it has undergone. So you have to find that. So let us compare the reactant and product sides. So in the reactant side, we are having SN4 plus. So tin is present in +4 oxidation state, and in product side it is present in +2 oxidation state. So here you are seeing that from +4 to +2, it is decrease in oxidation state. So what is decrease in oxidation state? It is reduction. So tin in +4 oxidation state has gained 2 electrons. So it has changed to +2 oxidation state. So here tin undergoes reduction, and whenever a species undergo reduction, it acts as what? It acts as oxidizing agent. So let us see the other compound, H2SO3. Let us find the oxidation state of sulfur in this compound. So +1 into 2 plus X minus 2 into 3 equal to 0. So 2 plus X minus 6 equal to 0. So I will continue here. So X minus 4 equal to 0, and the value of X is +4. So the oxidation state of sulfur is +4 in reactant side. Let us find in the product side also. +1 plus X minus 2 into 4 equal to -1. So 1 plus X minus 8 equal to -1. So I will continue here. X minus 7 equal to -1, and the value of X is +6. So in the product side, it is +6. So the oxidation state of sulfur has increased from +4 to +6. So it is increase in oxidation state, and increase in oxidation state is oxidation. So here H2SO3 has undergone oxidation, and whenever a species undergoes oxidation, it is going to act as a reducing agent. So now let us see the 4 options. SN4 plus is the oxidizing agent. So that is correct because it undergoes oxidation. That is wrong because SN4 plus undergoes what? It undergoes reduction. So option A is wrong. In option B, SN4 plus acts as the reducing agent is given. So that is also wrong. Option C, H2SO3 is the reducing agent. So that is correct because it undergoes oxidation. So option C is correct because H2SO3 undergoes oxidation, so it can act as reducing agent. Let us see option D also. H2SO3 is the reducing agent because it undergoes reduction. That is wrong because H2SO3 undergoes only oxidation. So the correct option is option C. H2SO3 is the reducing agent because it undergoes oxidation. The next question is, which one of the following cannot function as an oxidizing agent? Again, oxidizing agent is given. Oxidizing agent should undergo reduction. And how will we define reduction? Reduction is seen by the decrease in oxidation state. So, when a species from the given oxidation state undergoes decrease in oxidation state, it can act as a oxidizing agent. Let us see the first option, I minus. So, iodide ion is given. Here, iodine exhibits -1 oxidation state. So, iodine is already present in its lowest oxidation state because for iodine, the lowest oxidation state it can exhibit is -1 only. So, what is actually reduction? Reduction is gain of electron. Iodine can gain only 1 electron. So, it shows the lowest oxidation state of -1 only. So, further there is no decrease in oxidation state. So, for iodine, it cannot decrease its oxidation state further. So, when it cannot decrease the oxidation state further, it cannot act as an oxidizing agent. In question also, what is asked? Which of the following cannot function as an oxidizing agent? So, option A, I minus, cannot function as an oxidizing agent. Let us see the other options also. So the next option is sulfur. So the elemental form, in elemental form, sulfur is present as in oxidation state 0. So in elemental form, sulfur is present in oxidation state 0. So sulfur can decrease its oxidation state up to -2 in S2 minus. So from 0, it can change to -2. So it can undergo reduction. It can undergo reduction and it can act as a oxidizing agent. Let us see the next option, NO3 minus. So in NO3 minus, what is the oxidation state of nitrogen? X minus 2 into 3 equal to -1. X minus 6 equal to -1 and the value of X is +5. So nitrogen is present in +5 oxidation state. So nitrogen can further decrease its oxidation state to +4 in NO2 and it can decrease its oxidation state further to +2 in NO and -3 in NH3. Also, it can show 0 oxidation state in N2. So, from +5, it can lower its oxidation state. So, it undergoes reduction. So, when it undergoes reduction, it can act as what? It can act as oxidizing agent. Now, let us see the last option, Cr2O72 minus. So, we will find the oxidation state of chromium first. So, in option D, Cr2O72 minus 2x minus 14 because 7 oxygen atoms are there. So, -2 into 7 is -14 equal to -2. 2x is equal to +12. So, the value of x is +6. So, chromium present in +6 oxidation state. This chromium also, it can decrease its oxidation state to +3 in Cr3+. So, chromium also undergoes decrease in oxidation state. So, it means chromium also can undergo reduction in this +6 oxidation state. So, Cr6+ will show oxidizing property. So, it will act as oxidizing agent. So, the other 3 options can act as oxidizing agent. Iodine alone cannot undergo reduction. So, it cannot act as a oxidizing agent. The next question is, thiosulfate reacts differently with iodine and bromine in the reaction given below. So, 2 equations are given. Let us write the 2 equations in next page. The first equation is 2S2O3 2 minus plus I2 gives S4O6 2 minus plus 2I minus. Let us calculate the oxidation state of sulfur in reactant and product. 2x minus 2 into 3 equal to -2, 2x minus 6 equal to -2, 2x equal to +4 and the value of x is +2. So, in reactant, the oxidation state of sulfur is +2. Let us find in product 4x minus 2 into 6 equal to -2, 4x minus 12 equal to -2, 4x equal to +10. Value of x is 10 by 4, that is equal to 2.5. So, the oxidation state of sulfur increases from +2 to +2.5. So, increase in oxidation state is oxidation. So, thiosulfate undergoes oxidation. Now, let us see iodine. In the free form uncombined state, iodine is having the oxidation state of 0 and the iodide ion is having the oxidation state of -1. So, 0 to -1 is decrease in oxidation state. So, iodine undergoes reduction. Now, let us see the next equation. The next equation is S2O3 2 minus plus 5Br2 plus 5H2O gives 2SO4 2 minus plus 4Br minus. So, in this reaction, already for thiosulfate, we know the oxidation state of sulfur is +2 and in product, sulfate ions are present. In sulfate ions, I told that the oxidation state of sulfur will be +6. So, again it is increase in oxidation state from +2 to +6. So, it is oxidation. Increase in oxidation number is oxidation. Then bromine present in the elemental state. So, the oxidation state is 0 and in product it is present as Br minus. So, it is -1. So, from 0 to -1 is reduction. So with this, let us see the question. So in these two equations, thiosulfate in both the equations undergo oxidation. We saw that. So here I told thiosulfate, there is an increase in oxidation number. So it undergoes oxidation, and for I2 and Br2, they both undergo reduction. So now let us see the options. Bromine undergoes oxidation is given in first option. That is wrong because both iodine and Br2 undergoes reduction. So bromine undergoes oxidation is given. So the first statement is wrong. Second option, thiosulfate undergoes oxidation. That is correct by bromine and reduction by iodine. So the second statement is also wrong because in both the reactions, reaction with iodine as well as reaction with bromine, thiosulfate undergoes oxidation only. So in both the reactions, thiosulfate undergoes oxidation. But here they are telling it undergoes reduction by iodine. So the second statement is also wrong. Now the third and fourth statement. Bromine is a stronger oxidant than iodine. And fourth statement is bromine is a weaker oxidant than iodine. Now let us check that. Just see the difference in oxidation number in the reactant side and the product side for both the equations. For the first equation, the oxidation state of sulfur changes from +2 to +2.5. There is only a difference of 0.5. But in the second equation, the oxidation state of sulfur changes from +2 to +6. So the difference is large. The difference in oxidation state of sulfur is large in reaction with bromine. So the difference in oxidation state in iodine, in reaction with iodine, is less when you compare to bromine. So the difference in oxidation state of sulfur is large in case of bromine. So it suggests that bromine is a better oxidizing agent than iodine. Or you can also write bromine is a stronger oxidizing agent than iodine because the change in oxidation state, the difference in oxidation state in case of bromine is larger than in case of iodine. So the correct option is option C. Bromine is a stronger oxidant. What is oxidant? Oxidant is called as oxidizing agent. So bromine is a stronger oxidant than iodine. So the option C is the correct option. The next question is, among the following halogens, F2, Cl2, Br2 and I2, which one undergo disproportionation reaction? So what is the rule for disproportionation reaction? The same species should undergo both reduction and oxidation. How can we see that the same species undergone both reduction and oxidation? So the next rule is the same species should have both increase in oxidation state as well as decrease in oxidation state. So increase in oxidation state is oxidation and decrease in oxidation state is reduction. We all know that. So for a species, for the given species, both increase in oxidation state as well as decrease in oxidation state should be shown. Now let us see the options. So I will write F2 separately and the other three halogens Cl2, Br2 and I2 separately. So the given species are present in their uncombined state, in their free form. So in their elemental state, all these species will have the oxidation state of 0. Now from 0, either it should show the, now from 0, it should show both increase in oxidation state as well as decrease in oxidation state. So for Cl2, Br2 and I2, all the three species show and decrease in oxidation state of -1 in their ions like Cl minus, Br minus and I minus, and they show an increase in oxidation state of +1, +3 and +7 also. For example, chlorine will show a +1 oxidation state in sodium hypochlorite NaClO, and it will show a +3 oxidation state in sodium chlorite NaClO2, and it will show a +7 oxidation state in sodium perchlorite NaClO4, sodium perchlorate. So in these compounds, chlorine as well as with respect to bromine, iodine also, they will show a positive oxidation state. So these three species will show both increase in oxidation state as well as decrease in oxidation state. So these three species will show the disproportionation reaction, but for fluorine, other than zero oxidation state, it will not show positive oxidation state. So for fluorine, there is only decrease in oxidation state. So it can show only reduction, but it will not show oxidation. There is no positive oxidation state exhibited by fluorine. So fluorine will not undergo disproportionation reaction. So the condition for disproportionation reaction is the same species should undergo both reduction and oxidation. The same species should have both increase in oxidation state as well as decrease in oxidation state. For fluorine, there is only decrease in oxidation state from 0 to -1. There is no increase in oxidation state. So fluorine will not undergo disproportionation reaction. So which can undergo disproportionation reaction out of the four? Cl2, Br2 and I2 only. So the correct option is option B. The next question is, in acidic medium, K2Cr2O7 shows oxidizing action as represented in the half reaction Cr2O7 2- plus XH plus Y electrons gives 2A plus ZH2O. So in this half reaction, X, Y, Z and A are respectively. So you have to find X, Y and Z along with A. So in acidic medium, Cr2O7 2- is reduced to another ion. So the oxidation state of chromium in the Cr2O7 2- is +6. So we know that from +6 oxidation state, it will be reduced to +3 oxidation state. So if you see the options, in Cr2O3, what is the oxidation state of chromium? 2x minus 2 into 3 equal to 0, 2x minus 6 equal to 0. 2x equal to 6 and the value of x is +3. So here also the oxidation state of chromium is +3 and Cr3 plus is also given. So what is the answer? What is the correct option for A? Is it Cr2O3 or Cr3 plus? So already the coefficient is mentioned as 2 because 2 chromium atoms are present in the reactant site. Now if I write the first option Cr2O3, then 2 into 2, 4 chromium atoms are present in the product site, but only 2 chromium atoms are present in the reactant site. So that is wrong. So we cannot write Cr2O3. So the correct option, the correct answer for A is Cr3 plus. So we got the answer for A. So let us write the remaining H plus electrons plus H2O. Now let us find the remaining. So now you have to balance the oxygen atoms first. So 7 oxygen atoms are present in the reactant side and only 1 oxygen atom is given in the product side. So in front of water molecule, you have to write 7H2O. Now the reactant and product is balanced for the oxygen atoms. Then we will go to the hydrogen atoms. 7 into 2, 14 hydrogen atoms are present. So to balance that, you have to write 14 H plus in front of the H plus given in reactant side. Now you have to check the difference in oxidation state. Then you have to write the number of electrons. So I told that the oxidation state of chromium in Cr2O7 2- is +6. From +6, it is changed to +3. So what is the difference? The difference is 3 electrons. So one chromium atom has gained 3 electrons. So only there is a change of oxidation state from +6 to +3. But totally how many chromium atoms are there? 2 chromium atoms are there. So 3 into 2 equal to 6 electrons. So here you have to write the number of electrons as 6. So what is the value of X? The value of X is 14. Then the value of Y is 6. Then the value of Z is 7. So the answer 14, 6, 7. And what is the answer for A? A is Cr3 plus. So the correct option 14, 6, 7 and Cr3 plus is D. So the correct option is option D. Which of the following reactions are disproportionation reactions. So already we saw the condition for disproportionation reaction. So for a disproportionation reaction, the same species should undergo both reduction and oxidation. So how to identify reduction and oxidation? It means the same species should have both increase in oxidation state as well as decrease in oxidation state. So we can tell that the reactant should be present in intermediate oxidation state. So when it is present in intermediate oxidation state, it will show both increase in oxidation state as well as decrease in oxidation state. Now let us see the first option. Cu plus gives Cu2 plus Cu. So copper is present in +1 oxidation state and it is converted to +2 oxidation state and the elemental copper. So the oxidation state is 0. So from +1 to +2 is increase in oxidation state. So it is oxidation. And from +1 to 0 is decrease in oxidation state. So it is reduction. So here the same element undergoes both oxidation and reduction. So it is a disproportionation reaction. So the first equation is disproportionation reaction. Going to the second equation, 3MnO4 2 minus plus 4H plus gives 2MnO4 minus plus MnO2 plus 2H2O. Let us find the oxidation state of manganese in this given complex ion. X minus 2 into 4 equal to minus 2. X minus 8 equal to minus 2. I will continue here. X equal to minus 2 plus 8. So the value of X is plus 6. So manganese is present in plus 6 oxidation state in reactant. Now we will find the oxidation state of manganese in the products also. X minus 2 into 4 equal to minus 1. X minus 8 equal to minus 1 and the value of X is plus 7. So in this MnO4 minus, the value of manganese is plus 7. Then in MnO2, X minus 2 into 2 equal to 0. X minus 4 equal to 0 and the value of X is plus 4. So in reactant, it is present in plus 6 oxidation state and it is converted to plus 7 oxidation state in product. So it is increase in oxidation state. So it is oxidation. Then again from plus 6 oxidation state, it is also converted to plus 4 oxidation state. So it is decrease in oxidation state, decrease in oxidation state. So it is reduction. So the same species, same element undergoes both oxidation and reduction. So the option B, so the equation B is also showing disproportionation reaction. Let us see the remaining two equations in the next page. Next equation is 2KMNO4 gives K2MnO4 plus MnO2 plus O2. So in this equation, you have to find the oxidation state of manganese in reactant and product. Already we saw this. KMNO4 is nothing but MnO4 minus and K2MnO4 is MnO4 2 minus because the cation will have the charge of plus 1. So this whole complex ion will have the charge of minus 1 and here two potassium atoms are there. So it will have the charge of plus 2. So the other part will have the charge of minus 2. So in previous page itself, we found the oxidation state of manganese in MnO4 2 minus and MnO4 minus as well as MnO2. So in KMNO4, that is MnO4 minus, the oxidation state of manganese is plus 7 and in K2MnO4, the oxidation state of manganese is plus 6. Then in MnO2, the oxidation state of manganese is plus 4. So from plus 7, it is decreased to plus 6 as well as it is decreased to plus 4. So in both the cases, the oxidation state of manganese is decreased. So there is only decrease in oxidation state. So in both the cases, it is only reduction. So there is no oxidation. No oxidation in both the cases. So this is not a redox reaction. Sorry, not a disproportionation reaction. So this is the third equation. Let us go to the fourth equation. So the fourth equation is 2MnO4 minus plus 3Mn2 plus gives plus 2H2O gives 5MnO2 plus 4H plus. So here you have to see the oxidation state of manganese in reactant and product. So the oxidation state of manganese in MnO4 minus is plus 7. Then here it is present in plus 2 oxidation state. Then in product MnO2 is present. So here the oxidation state is plus 4. Let us compare the oxidation states. So from plus 7 decreased to plus 4. So it is reduction. Then from plus 2 it is increased to plus 4. So it is oxidation. But here the same species is not undergoing reduction and oxidation. Same element is undergoing reduction oxidation, but they are present in different compounds. So this type of reaction is called as comproportionation reaction. This is not a disproportionation reaction. This type of reaction is called as comproportionation reaction, where two reactants, so we are having the reactant 1 and reactant 2, two reactants in which the same element is present. Same element, manganese, is present. So same element in two different reactants with different oxidation states. So both the elements are present in different oxidation states. So they both combine. These two manganese ions combine to form a single product. They form a single product in which the oxidation state of manganese is intermediate. So the oxidation state of manganese is intermediate between the two reactants. So for one manganese atom it is plus 7 and the other one it is plus 2. But in product it is between plus 7 and plus 2. It is in the intermediate oxidation state plus 4. So they combine to form single product with intermediate oxidation state. So this type of reaction is not a disproportionation reaction, it is a comproportionation reaction. It is also called as sign proportionation. So instead of comproportionation we can tell sign proportionation reaction also. So here reduction and oxidation takes place for the same element, but the element is not present in the same compound. It is present in different compound. Different reactants are involved. So only in equation A and B it shows disproportionation reaction. So choose the correct answer from the options given below. Option A and B is the correct answer. Next question is, given below are two statements. Statement 1 and statement 2 is given. So we have to check whether the two statements are correct or incorrect. So let us see the statement 1. S8 solid undergoes disproportionation reaction to form S2 minus and S2O3 2 minus reaction under alkaline condition. So the given reaction is S8 undergoes disproportionation to give S2 minus plus S2O3 2 minus. So whether this is disproportionation or not. So you find the oxidation state of sulfur in the reactant and the products. The oxidation state of the elemental sulfur is 0 and the oxidation state of S2 minus sulfur is minus 2. Then for S2O3 2 minus 2x minus 2 into 3 equal to minus 2, 2x minus 6 equal to minus 2, 2x is equal to plus 4. So the value of x is plus 2. So this sulfur is having the oxidation state of plus 2. So for sulfur from 0 it is increased to plus 2. So it is obviously oxidation. Then again for sulfur from 0 it is decreased to minus 2. So it is reduction. So the same atom undergoes both oxidation and reduction. So it shows disproportionation reaction. So the statement 1 is correct. Now it is mentioned alkaline condition. So you have to balance this whole reaction. So let us see the balancing of this reaction. So the given reaction is S8 gives S2 minus plus S2O3 2 minus. So we have to see the half reactions separately. Let us see the reduction half reaction first. So instead of S8, let us first take sulfur alone. So S is converted to S2 minus. So the oxidation state of sulfur from 0 is changed to minus 2. So from 0 to minus 2, the difference is 2 electron and we know reduction is gain of electron. So reduction is gain of electron, that should be written in the reactant side. So S plus 2 electrons gives S2 minus. So this is the reduction half reaction. Now let us see the oxidation half reaction. So S, again we are taking S instead of S8. So S is converted to S2O3 2 minus. The oxidation state of sulfur changes from 0 to plus 2. But you have to balance the sulfur atoms first. So in reactant only one sulfur atom is there. In product you are having two sulfur atoms. So in the reactant you have to write 2S. Then see the change in oxidation state. The difference in oxidation state is 2 electrons. 2 electrons are lost. So the difference in oxidation state is 2, but 2 atoms are involved. So for one atom it is 2 means, then for 2 atoms it is 4. So 4 electrons are lost. Now you have to balance the oxygen atoms also. So in product you are having 3 oxygen atoms, but in reactant you are not having any oxygen atom. So you have to include 3 water molecules in reactant. So S2O3 2 minus plus 4 electrons. Now you see the hydrogen atoms. 3 into 2. 6 hydrogen atoms are present in the product's reactant side. But in product you are not having any hydrogen atom. So you have to write 3 into 2, 6H plus. But already in question it is mentioned that the reaction takes place in alkaline medium. So whenever you are adding H plus, you have to add OH minus on both sides. So the same number of OH minus should be added on both sides. So 2S plus 3H2O. Here you are having 6H plus, no? So you have to add 6 OH minus on both the sides. Gives S2O3 2 minus plus 4 electrons plus 6H plus 6 OH minus. Now this 6H plus and 6 OH minus we can write together. H plus and OH minus gives water molecule. So 6H plus and 6 OH minus will give 6H2O. Now you are having 3H2O in reactant and 6H2O in the product. So let us cancel that. Then here remaining you will get 3H2O. So the final equation oxidation half reaction is 2S plus 6OH minus gives S2O3 2 minus plus 3H2O. Then you are having the electrons, 4 electrons. So 4 electrons are involved in the oxidation half reaction, but only 2 electrons are involved in the reduction half reaction. So multiply this whole equation by 2. Then you will get 2S plus 4 electrons gives 2S2 minus. So this is equation 1 and equation 2. Now we are going to add both the equations. So first you will cancel the number of electrons. Then 2S and 2S will give 4S. So I will write here 4S. Then you are having the reactant 6OH minus gives. Then you are having 2S2 minus plus S2O3 2 minus plus 3H2O. Now you have to write sulfur as S8. Here you are having 4S. Now multiply this whole equation by 2. Then you will get 8S. 8S can be written as what? S8. 12 OH minus gives 4 S2 minus plus 2 S2O3 2 minus plus 6 H2O. So this is the final equation. So the final equation, balanced equation for this disproportionation reaction is S8 plus 12 H2O gives 4 S2 minus plus 2 S2O3 2 minus plus 6 H2O. So this is the final reaction and statement 1 is correct. Now let us go to statement 2. So the statement 2 is ClO4 minus can undergo disproportionation reaction under acidic condition. Is this statement correct or wrong? So the oxidation state of chlorine in ClO4 minus is X minus 2 into 4 equal to minus 1, X minus 8 equal to minus 1, and the value of X is plus 7. Chlorine is already present in its maximum oxidation state. The maximum oxidation state exhibited by chlorine is already plus 7. And here also it is present in plus 7 only. So further there is no oxidation. So in this compound, chlorine cannot undergo oxidation. It can only undergo reduction. Because what is oxidation? Oxidation is increase in oxidation state. But already chlorine is present in its maximum oxidation state of +7. So further there is no increase in oxidation state. It means further there is no oxidation. But what is meant by disproportionation reaction? Both oxidation and reduction should take place. But here only reduction takes place. So ClO4 minus cannot undergo disproportionation reaction. So what is the correct option? Statement 1 is correct, but statement 2 is incorrect. So the correct option is option A. Next question is number of moles of H plus ions required by 1 mole of MnO4 minus to oxidize oxalate ion to CO2 is. So H plus ions are mentioned. It means that the reaction takes place in acidic medium. So we are seeing the oxidation of oxalate ion to CO2. So let us see the oxidation half reaction. Oxalate ions C2O4 2 minus. In question itself it is mentioned that it is oxidized to CO2. First we will find the oxidation number of carbon in oxalate ions. 2x minus 2 into 4 equal to minus 2. 2x minus 8 equal to minus 2. 2x is equal to plus 6. X is equal to plus 3. So the oxidation state of carbon, one carbon atom is having the oxidation state of plus 3 in oxalate ion. Then in carbon dioxide, x minus 2 into 2 equal to 0. X minus 4 equal to 0. X is equal to plus 4. So obviously it is increase in oxidation state. So only it is called as oxidation. Now what is oxidation? Oxidation is loss of electron. How many electrons are lost? You have to see the change in the oxidation state. So the change in oxidation state is 1. But before that, you have to balance the number of carbon and the number of oxygen atoms. So let me erase this. So first, we will balance the number of carbon and oxygen atoms. In reactant side, 2 carbon atoms are there. In product, only 1 atom is there. So you have to write 2 CO2. Now the difference in the oxidation state for 1 carbon atom is 1. Then for 2 carbon atoms, it is 1 electron into 2. So the difference is 2 electrons. So loss of electron should be represented in the product side. So plus 2 electrons. Now we will write the reduction half reaction. Here MnO4 minus acts as the oxidizing agent. So itself it will undergo reduction. And also it is mentioned that the reaction takes place in acidic medium. So MnO4 minus is converted to Mn2 plus in acidic medium. So what is reduction? Reduction is gain of electron. How many electrons are gained? So in previous problems itself we saw the oxidation number of manganese in MnO4 minus is plus 7. Then in product the oxidation state of manganese is plus 2. So from plus 7 to plus 2. What is the change in oxidation state? 5 electrons are gained. So the difference in oxidation state from plus 7 to plus 2 is 5. So we know reduction is gain of electron. So the difference has to be written in the reactant side, plus 5 electrons. So now you have to balance the number of atoms. The number of manganese atom is already balanced. But 4 oxygen atoms are present in the reactant side. So in product you have to write 4 H2O. Then in product side you are having 4 into 2. 8 hydrogen atoms are there. So in reactant side you have to write 8 H plus. So now itself you got the answer. That is, here in reactant you are having 1 mole of MnO4 minus. 1 mole of MnO4 minus requires how many H plus? It requires 8 moles of H plus. So already you got the answer. But you have to equate the number of electrons also. So by equating the number of electrons, that is the number of electrons lost should be equal to the number of electrons gained. 2 electrons are lost and 5 electrons are gained. Both should be equated. So multiplying the first equation by 5 and the second equation by 2. So the equation you will get is 5C2O4 2 minus gives 10 CO2 plus 10 electrons. So let us keep this as equation 1. Then the next equation is 2 MnO4 minus plus 16H plus 10 electrons gives 2 Mn2 plus 8 H2O. So this is the second equation. So now you have to add both these equations. First let us cancel the number of electrons. So you have to add both the equations. 2MnO4 minus plus 5C2O4 2 minus plus 16H plus gives 2Mn2 plus 10CO2 plus 8H2O. So this is the final equation. In this final equation, 2 moles of MnO4 minus requires how many H plus ions? 16 H plus ions. Therefore, 1 mole of MnO4 minus requires 8 H plus ion, just the half of the first equation. So 2 moles require 16 H plus and 1 mole of MnO4 minus requires 8 H plus ion. So the answer is 8. 2 MnO4 minus plus Bi minus plus CH2O gives Xi2 plus YMnO2 plus ZOH minus. If the above equation is balanced with the integer coefficients, the value of Z is dash. So the given equation is 2MnO4 minus plus Bi minus plus CH2O gives Xi2 plus YMnO2 plus ZOH minus. So already a balanced equation is given, but the numbers are not given. Instead of that, alphabets are given. First, we have to balance the oxidizing agent and the reducing agent. Then we can balance the number of hydrogen atoms and the oxygen atoms. So how to balance the oxidizing and reducing agents? So we know that the number of electrons lost will be equal to number of electrons gained. So with that information, we can balance the number of manganese atoms and number of iodine atoms. So we know the oxidation state of manganese in MnO4 minus is +7 and in product MnO2 is present. So X minus 2 into 2 equal to 0, X minus 4 equal to 0 and the value of X is +4. So in product it is present in +4 oxidation state. So from +7 to +4, what is the difference? The difference is 3 electrons, but how many manganese atoms are there? 2 manganese atoms are there. So in reactant you are having 2 manganese atoms. Therefore in product also we should have 2 manganese atoms. So in front of the MnO2 you have to write 2 MnO2. So the value of Y is 2. So for 1 atom of manganese 3 electrons are gained. Then for 2 atoms 3 into 2 6 electrons are gained. So here you are having 2 MnO2. Then we will go to iodine. So I minus is converted to I2. By seeing the reactant and product itself, first we have to balance the number of atoms of iodine. I minus and I2 is given. So the number of iodine atoms in reactant is only 1. But in product 2 atoms are there. So here you have to write 2I minus. First you have to write 2I minus. Then we will proceed with the oxidation state. So for the iodide ion, the oxidation state is -1. Then for iodine elemental form, the oxidation state is 0. So from -1 to 0, what is the difference? The difference is 1 electron. But how many iodine atoms are involved? 2 iodine atoms are involved. So 1 electron into 2. So that is equal to 2 electrons. So the number of electrons gained is 6. The number of electrons lost is 2. But both have to be the same. They both have to be equated. So what is the easiest way? The easiest way is multiplying the number of electrons lost by 3. So the oxidation half reaction is multiplied by 3. So already we are having 2I minus, no? Here you have to multiply by 3. So the reactant is now having how many I minus? 6 I minus is present. So let us write that 6 I minus is involved. Then in product also 6 iodine atoms should be present. Already 2 iodine atoms are there. I2 is there. So here you have to write 3 to balance with the reactant. 3 I2. So now we have already balanced the oxidizing agent and the reducing agent. So let us write that now. 2MnO4 minus plus 6I minus plus CH2O gives 3I2 plus 2MnO2 plus ZOH minus. So up to this we have balanced. Now we are going to balance the number of oxygen atoms and then the number of hydrogen atoms. So here in product OH minus is mentioned. So it means that the reaction takes place in basic medium. So let us keep that in mind. So first let us leave this H2O and OH minus. Let us do the normal balancing. MnO4 minus plus 6I minus gives 3I2 plus 2MnO2. So if you see the reactant side, how many oxygen atoms are there? 2 into 4, 8 oxygen atoms are there. But in product, 2 into 2, only 4 oxygen atoms are present. So to balance the number of oxygen atoms, in product side, you have to write 4H2O. So now how many hydrogen atoms are there in the product side? 4 into 2, 8 hydrogen atoms are there in the product side. So to balance that, you have to write 8H plus in the reactant side. But already I told the reaction takes place in basic medium. So when you write H plus, you should also write the equal number of OH minus on both the side. So in reactant side also you have to write 8 OH minus, and in product side also you have to write 8 OH minus. So now the reactant is having 8 H plus and 8 OH minus. This H plus and the OH minus together makes H2O, that is water molecule. So we can write that combined 2MnO4 minus plus 6I minus plus 8H2O gives 3I2 plus 2MnO2 plus 4H2O plus 8OH minus. So in reactant side also H2O is present, and in product side also H2O is present. Cancel that. Cancel that. So 4H2O, 8H2O is cancelled, and here you will get the remaining 4H2O. So now this final equation is same as given in the question. So let us write the final equation from the last one. 2MnO4 minus plus 6I minus plus 4H2O gives 3I2 plus 2MnO2 plus 8OH minus. So now the value of Z is 8. So in above equation, the value of Z is 8. So I hope you understood this question. Next question is, total number of species from the following which can undergo disproportionation reaction is. So 9 species are given, and the condition to undergo disproportionation reaction. So already I told what is disproportionation reaction. Here we will see the condition. Conditions for disproportionation reaction. So the species should exhibit at least 3 different oxidation states. So the species should exhibit minimum of at least 3 different oxidation states. And the second condition is the species should be in intermediate oxidation state. So for example, you can take oxygen. Oxygen exhibits -2 oxidation state, -1 oxidation state, as well as 0 oxidation state. And in OF2 compound, it exhibits +2 oxidation state also. So it is having at least 3 different oxidation state. So only in compound OF2 it is having +2 oxidation state. Let us not see that. So it is having 3 different oxidation state, and only when it is present in this intermediate oxidation state, only when it is present in the intermediate oxidation state, then it will show the disproportionation reaction. So this is the condition. Now let us see the given species H2O2, hydrogen peroxide. So already I told the oxidation state of oxygen in hydrogen peroxide is -1. So it is obviously the intermediate oxidation state. So hydrogen peroxide will show disproportionation reaction. Then the next one is ClO3 minus. So we have to find the oxidation state of chlorine. So X minus 2 into 3 is 6 equal to -1. So the value of X is +5. So the oxidation state of chlorine is +5. So this is also the intermediate oxidation state, because the oxidation state of chlorine, it shows a maximum oxidation state of +7. So I will write that. So the maximum oxidation state shown by chlorine is +7, and the minimum oxidation state shown by chlorine is -1. So this +5 is in between the +7 and -1. So it will undergo disproportionation reaction. Then going to P4. So in elemental state, phosphorus is having the oxidation state of 0, and phosphorus shows the maximum oxidation state of +5 and minimum oxidation state of -3. So it is the intermediate oxidation state. So obviously it will undergo disproportionation reaction. Then the next one is Cl2. So phosphorus undergoes disproportionation. The next one is Cl2, where chlorine is having the elemental oxidation state of 0. So already I wrote that chlorine shows a maximum oxidation state of +7 and minimum oxidation state of -1. So it is in between. So Cl2 also undergoes disproportionation reaction. Then silver. Silver does not undergo disproportionation reaction, because in elemental state already the minimum oxidation state of 0 is exhibited by silver. So for silver, it can exhibit a maximum oxidation state of +1 and a minimum oxidation state of only 0. So already it is present in 0 oxidation state. It is not the intermediate oxidation state. The next one is Cu plus, copper in +1 oxidation state. So copper can exhibit a maximum oxidation state of +2 and a minimum oxidation state of 0. So here it is in intermediate oxidation state. So Cu plus can undergo disproportionation reaction. The next one is F2. Fluorine in elemental state is having the oxidation state of 0. So the maximum oxidation state exhibited by fluorine is 0 only, and the minimum oxidation state it exhibits it's -1. So at least 3 different oxidation states should be there, but for fluorine it exhibits only 2 different oxidation states, and it is already present in 0 oxidation state. So fluorine will not undergo disproportionation reaction. The next one is NO2. So here nitrogen is present in +4 oxidation state. So the maximum oxidation state nitrogen can exhibit is +5, and minimum oxidation state it can exhibit is -3. So here it is present in intermediate oxidation state. So it will undergo disproportionation reaction. Then the next one is K+. So potassium is a group 1 element. So already it is now present in +1 oxidation state. So the maximum oxidation state it can exhibit is +1, and the minimum oxidation state it can exhibit is 0 only. So only 2 different oxidation states are there, but the condition is it should at least exhibit 3 different oxidation states. So potassium is having only 2 different oxidation states, so it will not undergo disproportionation reaction. So the total number of species which can undergo disproportionation reaction is 1, 2, 3, 4, 5, 6. So the answer is 6. Next question is, chlorine undergoes disproportionation in alkaline medium as shown below. ACl2 plus BOH minus gives CClO minus plus DCl minus plus EH2O. So the oxidation state of elemental chlorine is 0. Then the oxidation state of chlorine in ClO minus, X minus 2 equal to -1. So the value of X is +1. Then the oxidation state of chlorine in Cl minus is -1. So one chlorine atom has increase in oxidation state, so it is oxidation. Then the other chlorine atom has decrease in oxidation state, so it is reduction. So it undergoes disproportionation reaction. And if you see the number of chlorine atoms, already they are balanced. 2 chlorine atoms are present in the reactant side, and 1 chlorine atom in ClO minus and 1 chlorine atom in Cl minus. So the number of chlorine atoms are already balanced. So the coefficient for Cl2, ClO minus and Cl minus is 1. Now we can balance the remaining, that is oxygen and hydrogen atoms. So first let us just see the oxygen and hydrogen atoms present in the reactant sites and product sites. So the number of oxygen atom present in the reactant side is 1, and the product side is, in ClO minus you are having 1 atom and H2O you are having 1 atom. So 2 atoms are present. then the number of hydrogen atoms in reactant side is 1. Then in product side, H2 is present. So 2 atoms are present. So the number of oxygen and hydrogen atoms is less in the reactant side than the product side. So you have to balance just the reactant side by putting 2 in front of OH minus. So this is the overall balanced reaction. So no need to see the half reactions because already the number of electrons are same. The number of electrons loss is equal to number of electrons gain. So we have balanced the oxygen and hydrogen atoms. So what are the coefficients? 1, 2, 1, 1, 1. So the coefficients are 1, 2 and 1. So this is the coefficient. Now I will also show the balancing of the half reactions also. So the given equation is Cl2 plus OH minus gives ClO minus plus Cl minus plus H2O. So first let us see the reduction half reaction. So the reduction half reaction is Cl2 is converted to Cl minus. So from 0 oxidation state it is decreased to -1. So what is reduction? Reduction is gain of electrons. So what is the difference? The difference is 1 electron. But you have to balance the number of chlorine atoms. So the product has 2 Cl minus. So for 1 chlorine atom, the difference is 1 electron. Therefore, for 2 chlorine atoms, 2 electrons are gained to give 2 Cl minus. Now let us see the oxidation half reaction. So Cl2 is converted to ClO minus. Again, you have to balance the chlorine atoms. Then the oxidation state changes from 0 to +1. So the difference is 1 electron for 1 chlorine atom. Therefore, for 2 chlorine atoms, it is 2 electrons. So plus 2 E minus. Now you have to balance the oxygen atoms. 2 oxygen atoms are present in the product side. So you have to write 2 H2O in the reactant side gives 2 ClO minus plus 2 electrons. Then you have to balance the hydrogen atoms. So 4 hydrogen atoms are present in the reactant side. So you have to write 4H plus in the product side. But already it is mentioned that the reaction is happening in alkaline medium. So you have to add equal number of OH minus on both sides. Cl2 plus 2H2O plus we have added 4H plus. So therefore you have to add 4OH minus on the reactant as well as the product side. 2 electrons plus 4H plus 4OH minus. So we have added 4OH minus on both sides. Now we know that H plus and OH minus together will make water molecule. So here you are having 4H2O. Therefore you can cancel 2H2O and 4H2O. So remaining you will be having 2H2O. So the final oxidation half reaction is Cl2 plus 4OH minus gives 2 ClO minus plus 2H2O plus 2 electrons. So now the number of electrons are already equal. So we can add the two equations 1 and 2. So we can cancel the electrons on the reactant and product side. Then you are having Cl2 on both the equations. Cl2 plus Cl2 gives 2 Cl2 plus 4OH minus gives 2 ClO minus plus you are having 2 Cl minus plus 2H2O. So in this equation, you can divide the coefficient by a common multiple 2. So you are having Cl2 plus 2OH minus gives ClO minus plus Cl minus plus H2O. So what is the coefficient? 1, 2, 1, 1, 1. So the coefficient, so again we are getting the same coefficient only. So the correct answer is option B. Next question is, see the following chemical reaction. Cr2O7 2 minus plus XH plus 6Fe2 plus gives YCr3 plus 6Fe3 plus ZH2O. So in this reaction, if you see the charge of ion, Fe2 plus is converted to Fe3 plus. Increase in oxidation state is oxidation. So what is the difference in charge? From 2 plus it is changed to 3 plus. So the difference is 1 electron. So 1 electron is lost. But how many ion atoms are mentioned? 6 ion atoms are mentioned. So 1 electron into 6 equal to 6 electrons. Now if you see the oxidation state of chromium in Cr2O7 2 minus, it is plus 6 and H plus is mentioned. So what does this H plus refers? It refers to acidic medium. So in acidic medium, chromium is converted to Cr3 plus. And how many atoms are present in the reactant? 2 Cr is present. So the product will have 2 Cr3 plus. So the oxidation state changes from plus 6 to plus 3. So decrease in oxidation state is reduction. And what is the difference? The difference is 3 electrons. And how many atoms are involved? 2 atoms are involved. So 3 into 2 is equal to 6 electrons. So already the number of electrons are same only. The number of electrons are equal. It means the number of equivalents of the oxidizing agent and the reducing agent are same. So already the reaction is half balanced. So you have to balance the remaining, that is hydrogen and oxygen alone. So let us write that. So let us write the equation. Cr2O7 2 minus plus 6Fe2 plus gives 2Cr3 plus 6Fe3 plus. So now you have to balance the oxygen atoms, then the hydrogen atom. So how many oxygen atoms are present in the reactant side? 7 oxygen atoms are there. So in product you have to write 7H2O. Then how many hydrogen atoms are present in the product side? 7 into 2, 14 hydrogen atoms are present. So in reactant side you have to write 14H plus. So now what is the value of X? The value of X is 14. Then the value of Y is 2. Then the value of Z is 7. Question is the sum of X, Y and Z is. So the sum of X plus Y plus Z is equal to 14 plus 2 plus 7 is equal to 16 plus 7, that is 23. So the answer is 23. Next question is 2IO3 minus plus Xi minus plus 12H plus gives 6I2 plus 6H2O. What is the value of X? This question is very simple because you have to find the value of only one coefficient. So for this question, you can go through the procedure of equating the charges on both sides. So let us see the overall charge on the reactant side and the product side. So you are having 2 minus. So minus 2, then X minus. So plus minus X. Then how many positive charges are there? 12 positive charges are there. So plus 12 gives the product side is neutral. So we are going to write 0. So in this equation, the reactant side and product side should have the same charge. In all the equations, the charges should be equal. And in this question, only one variable you have to find. So we can go by this procedure itself, that is overall charge should be equated. So minus 2 minus X plus 12 is equal to 0. So 10 minus X equal to 0. So let us take X to the other side. So X will be equal to plus 10. So the value of X is 10. So you can go by this method, that is equating the overall charge, or you can also go by the normal method, that is half reaction method. You can also go by the half reaction method also. So I will explain that one also. So the given equation is 2IO3 minus plus Xi minus plus 12H plus gives 6I2 plus 6H2O. So first let us see the oxidation state of reactant and product. So the oxidation state of iodine in this IO3 minus is X minus 2 into 3 equal to minus 1, X minus 6 equal to minus 1. So the value of X is plus 5. So plus 5 is the oxidation state of iodine. Then the oxidation state of iodine in iodide ion is minus 1. Then the oxidation state of iodine in this elemental form I2 is 0. So first let us see the process. From plus 5 to 0, it is decrease in oxidation state. So it is reduction. Then from minus 1 to 0, it is increase in oxidation state. So it is oxidation. So let us see the half reactions of reduction and oxidation separately. So first, let us not see the coefficients and we will do the balancing by ourselves. So IO3 minus gives I2. So here we are not seeing the coefficients and all, we are going to balance by ourselves. So first we have to balance the iodine atoms. So 2IO3 minus gives I2. Then the charge oxidation state is plus 5 to 0. So what is the difference? The difference is 5 electrons and 2 atoms are involved. So 5 into 2, 10 electrons are gained. We know reduction is gain of electron. Now you have to balance the oxygen atoms. So 2 into 3, 6 oxygen atoms are there in the reactant side because you are having the coefficient 2. So 2 into 3, 6 oxygen atoms. So in product, you have to write 6 H2O. Then how many hydrogen atoms are there? 6 into 2, 12 hydrogen atoms are there in the product side. So in reactant side, you have to write 12 H plus gives I2 plus 6 H2O. So this is the reduction half reaction. Now we will go to the oxidation half reaction. So the oxidation half reaction is I minus gives I2. So you have to balance the iodine atoms. So the reactant has 2 I minus. So we know oxidation is loss of electrons. So see the oxidation state from -1 to 0. The difference is 1 electron. But how many atoms are involved? 2 atoms are involved. So 1 into 2, 2 electrons are lost. Here you are having 10 electrons, but here you are having only 2 electrons. So the overall oxidation half reaction is multiplied by 5. So 10 I minus gives 5 I2 plus 10 electrons. So we are going to add the first equation and the second equation. We can cancel the number of electrons. So you are having 2 IO3 minus plus, then you have to write this one, 10 I minus plus 12 H plus gives I2 is there in first equation and 5 I2 is there in the second equation. So I2 plus 5 I2 is 6 I2 plus 6 H2O. So we got the same reaction. And what is the value of X? The value of X is 10. So in both the ways, you will get the same answer. The value of X is 10. The next question is, which of the following options are correct for the reaction? 2AuCN twice minus plus Zn gives 2Au plus ZnCN 4 times minus 2. So let us find the oxidation state of gold in the first complex AuCN twice minus. So X and the charge of cyanide ion is -1 into 2 ions are present equal to -1. X minus 2 equal to -1 and the value of X is +1. So the oxidation state of gold is +1 in reactant and in product it is present in the free form. So the oxidation state is 0. So let us write the equation here. AuCN twice minus plus Zn gives 2Au plus ZnCN 4 times minus 2. So the oxidation state of gold changes from +1 to 0. So it is decrease in oxidation state. So it is reduction. Then the oxidation state of zinc in the elemental form is 0. Now we will find the oxidation state of zinc in this complex ZnCN4 minus 2. X minus 1 into 4 equal to -2, X minus 4 equal to -2 and the value of X is +2. So for zinc it is the change is in oxidation state is 0 to +2. So it is increase in oxidation state. So it is oxidation. So this reaction has oxidation and reduction. So it is a redox reaction. Then the other options you have to check whether this is a displacement reaction. Yes, it is a displacement reaction because zinc displaces gold from the compound and zinc forms another compound with the cyanide ion. So it is a displacement reaction. Why it is a displacement reaction is because zinc displaces gold from this compound AuCN twice. It is not a decomposition reaction or a combination reaction. Decomposition reaction means a single compound, single reactant should decompose. So it is not a decomposition reaction, and a combination reaction is 2 or more reactants should combine to form a common product. So it is not a combination reaction also. So the correct option is option A and B only. Next question is, which of the given reactions is not an example of disproportionation reaction? So already we told disproportionation reaction means the same species should undergo both oxidation and reduction. So there should be decrease in oxidation state as well as increase in oxidation state. So let us see the four equations. So in option A, the oxidation state of oxygen in hydrogen peroxide is -1. In water molecule, it is -2. And in oxygen molecule, it is 0. So there is decrease in oxidation state as well as increase in oxidation state. So the same element undergoes both oxidation as well as reduction. So this is a disproportionation reaction. Then the oxidation state of nitrogen in NO2 is +4, then nitrogen in HNO3 is +5, then in HNO2 the oxidation state of nitrogen is +3. So here also from +4 to +5 is increase in oxidation state, so it is oxidation, and from +4 to +3 is decrease in oxidation state, so it is reduction. So both oxidation and reduction takes place, so this is also a disproportionation reaction. Then the oxidation state of manganese in MnO4- is +7, and in product you are having only one manganese atom in one compound, MnO2. So the oxidation state of manganese in MnO2 is +4. So there is only decrease in oxidation state. So only reduction takes place in this third equation. So it is not a disproportionation reaction. Then, so the correct option here, they are asking which is not an example of disproportionation reaction. So the correct option is option C. Then the last equation, the oxidation state of manganese in MnO4- is +6. Then the oxidation state of manganese in MnO4- is +7. Then the oxidation state of manganese in MnO2 is +4. So there is decrease in oxidation state as well as increase in oxidation state. So both oxidation and reduction takes place. So this is also disproportionation reaction. So which is not an example of disproportionation reaction? Option C. Next question is, which one of the following is disproportionation reaction? So again, both oxidation and reduction should take place in the same element, same species. So how to identify oxidation? Oxidation is increase in oxidation state. Then reduction is decrease in oxidation state. So let us see the four equations. The oxidation state of manganese in MnO4- is +6. So already we have seen the calculation of oxidation of oxidation state of manganese. So already we have seen the calculation of how to calculate the oxidation state of manganese in MnO4- MnO4- and MnO2. So I am directly writing the oxidation states. In previous question also I directly wrote the oxidation state. So the oxidation state of manganese in MnO4- is +7. Then the oxidation state of manganese in MnO2 is +4. So there is increase in oxidation state as well as decrease in oxidation state. So there is both oxidation and reduction taking place in the same element. So the first one is the example of disproportionation reaction. Now let us see the other equations also. The oxidation state of manganese in MnO4- is +6. So in reactant it is having +6 oxidation state. In product it is in MnO2. So the oxidation state is +4. So there is only decrease in oxidation state. What is decrease in oxidation state? It is reduction. So reduction alone takes place. So this is not a disproportionation reaction. So the next equation is same MnO4- the oxidation state is +6. Then it is converted to Mn2+. So from +6 to +2. So again decrease in oxidation state. So reduction alone takes place. Then MnO4-, the oxidation state of manganese is +7. Now it is converted to MnO2. So the oxidation state of manganese is +4. So here also there is decrease in oxidation state. So there is only reduction. So in all the three equations, manganese undergo reduction. Now we will see which element undergoes oxidation. So the option B given is reduction half reaction. So this is a half reaction. So we can't see which element is oxidized here. Then in option C, the oxidation state of iodine is -1 in reactant, and in product it is 0. So from -1 to 0 is increase in oxidation state. So here iodine undergoes oxidation. Then S2O3- the oxidation state of sulfur is +2. Then in SO4- the oxidation state of sulfur is +6. So again increase in oxidation state. So it is oxidation. So B, C, D are regular redox reactions, but option A is only disproportionation reaction. So the correct option is option A. Next question is the species given below that does not show disproportionation reaction. So again the same reaction. So here disproportionation reaction we are talking about. So you have to see whether the species can undergo both reduction and oxidation, that is both increase in oxidation state as well as decrease in oxidation state. You have to see that. So let us find the oxidation state of bromine in all the four options. So in BrO4 minus x minus 2 into 4 equal to minus 1, x minus 8 equal to minus 1, and the value of x is plus 7. So the next option, BrO minus x minus 2 equal to minus 1, x is equal to plus 1. BrO2 minus x minus 2 into 2 equal to minus 1, x minus 4 equal to minus 1, and the value of x is plus 3. Then BrO3 minus x minus 2 into 3 equal to minus 1, x minus 6 equal to minus 1, and the value of x is plus 5. So out of all the 4 options, in first option, bromine is already present in the highest oxidation state. So there is no further increase in oxidation state. So which means what? No further oxidation. So if it cannot undergo oxidation, it means it can undergo only reduction. So it means it cannot undergo disproportionation reaction. Why? Because in disproportionation reaction, the species should undergo both oxidation and reduction. But in first compound, first species, bromine is already present in the highest oxidation state. So there is no further increase in oxidation state. It means there is no further oxidation. So the correct option is option A, because here they are asking which does not show the disproportionation reaction. So the correct option is option A. Next question is 2MnO4 minus plus BC2O4 2 minus plus CH plus gives XMn2 plus YCO2 plus ZH2O. If the above equation is balanced with integer coefficients, the value of C is dash. So let us see the oxidation state of the oxidizing agent and the reducing agent. So the oxidation state of manganese in MnO4 minus is plus 7, and in the product it is in Mn2 plus oxidation state. So it is plus 2. So from plus 7 to plus 2, the difference is 5 electrons. Here you are having 2 MnO4 minus. So the value of X will also be equal to 2 manganese atoms in product. So for one atom, the difference is 5 electron. Then for 2 atoms, 5 into 2 equal to 10 electrons. So the next one is the oxidation state of carbon. The oxidation state of carbon in C2O4 2 minus is plus 3, and the oxidation state of carbon in carbon dioxide is plus 4. First, let us balance the number of carbon atoms in reactant and product. 2 carbon atoms are present initially in the reactant, but only 1 carbon atom in product. So first, let us write 2 CO2. So just for time being, we are writing 2 CO2. Then you have to balance the number of electrons. So what is the difference in oxidation state from plus 3 to plus 4? So it is, the difference is 1 electron. But how many carbon atoms are involved? 2 carbon atoms are involved. So 1 into 2, 2 electrons are lost. So the oxidation of oxalate ions C2O4 2 minus, the difference in oxidation state is 1 electron, but 2 atoms are involved. So 1 into 2 gives 2 electrons. But the number of electrons gained is 10, but the number of electrons lost is 2 only. So how to equate that? So multiply the oxidation half reaction by 5. That means you have to multiply the coefficient also by 5. So if you write 5 C2O4 2 minus, here already you are having 2. So 2 into 5 will give 10 CO2. Now this 2 electrons into 5 will give 10 electrons. So somehow we have balanced the number of electrons also. So now the number of atoms, that is the species undergoing oxidation and reduction, for them also the number of atoms are balanced. So let us write the equation now. 2MnO4 minus plus 5C2O4 2 minus. So the value of B is 5. So for time being, let us not write the H plus, gives 2Mn2 plus the value of Y is 10 CO2. How we got 10? First you have to balance the carbon atoms. So for that you have to write 2, then multiplying the whole equation by 5. So 2 into 5 will give 10, plus let us not write the H2O now. So now let us balance the number of oxygen atoms in the reactant and the product side. So you are having 2 into 4, 8 oxygen atoms in MnO4 minus in this species. Then 5 into 4, 20 oxygen atoms are present in this species. Here you are having in product side 10 into 2. Here also 20 oxygen atoms are there. Here 20 oxygen atoms. And in product also carbon dioxide is having 20 oxygen atoms. So let us not bother about C2O4 minus and CO2. So let us just see MnO4 minus. So the number of oxygen atoms are 2 into 4, 8 H2O. So to balance the number of oxygen atom in the product side, I am writing 8 H2O. Now you have to balance what? You have to balance the hydrogen atoms. How many hydrogen atoms are there? 8 into 2, 16 hydrogen atoms are there. So in reactant, you have to write 16 H plus. So again, I will explain the number of oxygen atom in the oxalate ion is 20. 20 oxygen atoms are there. And in carbon dioxide also 10 into 2, 20 oxygen atoms are present. So no need to bother about these two species. So we are only balancing the MnO4 minus in which the oxygen atom is present. So the number of oxygen atom is 2 into 4, 8. So you have to balance the oxygen atom by writing 8 H2O. Then 8 into 2, 16 hydrogen atoms are there. So 16 H plus. So already the number of electrons are equated. So the number of electrons are cancelled. Then only we are getting this equation. So the question is, if the above equation is balanced with integer coefficient, the value of C is, what is the value of C? C is the coefficient of H plus. So what is the coefficient of H plus? 16. So the value of C is 16. I hope you understood this question. The next question is, the reaction of sulfur in alkaline medium is given below. S8 plus AOH minus gives BS2 minus plus CS2O3 2 minus plus DH2O. Already I have explained the balancing of this equation. So let us see the half reactions separately. The elemental form of sulfur is having the oxidation state of 0. Then in product, S2 minus is having the oxidation state of minus 2. Then S2O3 2 minus, the oxidation state of sulfur is plus 2. So let us see the oxidation half reaction and reduction half reaction. First, let us take the reduction half reaction. So in previous question, I have explained using sulfur alone. So in question S8 is given. In previous question, I took S alone. Then only I explained. But in this question, let us take S8 itself. S8 is reduced to what? S2 minus. How I am telling it is reduction? From 0 to minus 2. Decrease in oxidation state is reduction. Then from 0 to plus 2. Increase in oxidation state is oxidation. So S8 is reduced to S2 minus. First balance the sulfur atoms. So product you have to write 8 S2 minus. Now see the difference in charge. From the oxidation state 0, it is changed to minus 2. So the difference is minus 2 means it is 2 electrons. 2 electrons are gained. Reduction is gain of electron. So 2 electrons are gained. Then how many sulfur atoms are there? 8 sulfur atoms are there. So 2 into 8, 16. 16 electrons are gained. So this is the reduction half reaction. Now let us see the oxidation half reaction. So S8 is converted to S2O3 2 minus. So the oxidation state of sulfur in S8 is 0. Then in S2O3 2 minus it is plus 2. First let us balance the sulfur atoms. So here you are having 8 sulfur atoms. In product you have to write 4 S2O3 2 minus. Now what is the difference in oxidation state? From 0 to plus 2, the difference is 2. But how many sulfur atoms are involved? Totally 8 sulfur atoms are involved. So 2 into 8 is 16. So 16 electrons are lost. Now let us balance the oxygen atoms. 4 into 3, 12 oxygen atoms are present in the product. So S8 plus 12 H2O gives 4 S2O3 2 minus plus 16 electrons. Then now you have to balance the hydrogen atoms. 12 into 2, 24 hydrogen atoms are there. So you have to write 24 H plus in the product side. Then now it is mentioned that alkaline medium is used. So you have to add equal number of OH minus on both sides. So how many H plus is added? Same number of OH minus should be added. So S8 plus 12 H2O plus 24 OH minus gives 4 S2O3 2 minus plus 16 electrons plus 24 H plus plus 24 OH minus. Then already I told H plus and OH minus together will form H2O. So 24 H2O is present. Now we can cancel 12 H2O from 24 H2O. So in product you will get 12 H2O, remaining 12 H2O. So the final oxidation of reaction is S8 plus 24 OH minus gives 4 S2O3 2 minus plus 12 H2O plus 16 electrons. So let us add the reduction half reaction and the oxidation half reaction. So in the reactant, S8 and S8 is present on both the equations. So it will give 2 S8 plus, you can cancel the 16 electrons in the reactant and product side. So plus 24 OH minus gives 8 S2 minus plus 4 S2O3 2 minus plus 12 H2O. So in this equation, everything is a multiple of 2. So we are going to divide this whole equation by 2. Then what will we get? S8 plus 12 OH minus gives S2 minus plus, 4 S2 minus plus 2 S2O3 2 minus plus 6 H2O. So this is the final balanced equation. Now what is the question? The value of A is, so what is the value of A? A is the coefficient of OH minus. So what is the coefficient of OH minus? It is 12. So the value of A is 12. Next question is, consider the following equations. 2Fe2 plus H2O2 gives XA plus YB in basic medium. Then another equation is given. 2MnO4 minus plus 6H plus 5H2O2 gives X dash C plus Y dash D plus Z dash E in acidic medium. The sum of stoichiometric coefficients for products A, B, C, D and E respectively is. So you have to balance both the equations separately, then you have to add the coefficients. So first let us see the first equation. So Fe2 plus is given. So we know that Fe2 plus will be oxidized to Fe3 plus. So let us see the oxidation half reaction. Fe2 plus will be converted to Fe3 plus and already 2 Fe2 plus is given. So in product also 2 Fe3 plus will be there. Then we know oxidation is loss of electron. How many electrons are lost? The oxidation state changes from +2 to +3. So the difference is 1 electron. And how many atoms are there? 2 atoms are there. So 1 into 2, 2 electrons are lost. So this is the oxidation half reaction. Then we will go to the reduction half reaction. So we know reduction is gain of electrons. So in oxidation 2 electrons are lost. That 2 electrons will be gained by hydrogen peroxide. H2O2 will gain the 2 electrons plus 2 electrons and reduction of hydrogen peroxide will take place. So it is reduced to H2O, water molecule. The oxidation state of oxygen in hydrogen peroxide is -1 and in oxygen atom in water molecule is -2. So it is decrease in oxidation state. So it is reduction. So now you have to balance the number of oxygen atoms. 2 oxygen atoms are present in the reactant side. But in product side only 1 oxygen atom is present. So in front of water molecule you have to write 2. But now see the hydrogen atoms. 2 into 2, 4 hydrogen atoms are present in the product side, but only 2 hydrogen atoms are present in the reactant side. So the remaining 2 hydrogen atoms you have to write as 2H plus. But already it is mentioned, it is in basic medium. So whenever you add H plus, you have to add OH minus also. H2O2 plus 2 electrons plus 2H plus 2OH minus gives 2H2O. In product side also you have to write 2OH minus. Then already I told H plus and OH minus together will make H2O. So in reactant 2H plus and 2OH minus will make 2H2O. So in reactant side also you are having 2H2O and in product side also you are having 2H2O. So let us cancel that. So the overall reduction half reaction I will write here H2O2 plus 2 electrons gives 2OH minus. So this is the reduction half reaction. So you have to add the reduction half reaction and the oxidation half reaction. So when you add them, you will get the same. So in reactant, you are having 2Fe2 plus. Here also you are having 2Fe2 plus. H2O2 is present. Here also H2O2 is there. Then what is the product? 2Fe3 plus. So here the product is 2Fe3 plus here you are having 2OH minus. So YB is 2OH minus. So I will erase that and write. So XA and YB is 2Fe3 plus 2OH minus. So the value of X is 2 and the value of Y is also 2. Now in same way you have to balance the second equation also. Let us do that in the next page. So the equation is 2MnO4 minus plus 6H plus 5H2O2 gives, so the product is given as H dash C plus Y dash D plus Z dash E. Let us not write that. First, let us see the equation. We know KMnO4, that is MnO4 minus, is a powerful oxidizing agent. So it is going to oxidize the other substance, that is hydrogen peroxide. So let us see the oxidation half reaction of hydrogen peroxide. Hydrogen peroxide, during the oxidation process, it will be oxidized to O2. How to find that? The oxidation state of oxygen in hydrogen peroxide is -1 and in oxygen molecule it is 0. So increase in oxidation state is oxidation. Then how many electrons are lost? The change is from -1 to 0. The number of electrons is 1. But how many atoms are involved? 2 atoms are involved. So 2 electrons are lost. So why it is written in the product side? Oxidation is loss of electron. Then you have to balance the hydrogen atoms also. 2 hydrogen atoms are present in reactant side. So in product you have to write 2H plus. So this is the oxidation half reaction. Now let us go to the reduction half reaction. So the reduction half reaction of MnO4 minus. So already 2 MnO4 minus is mentioned. So first let us not bother about the 2. So we know that it is already mentioned acidic medium. In acidic medium, MnO4 minus will be converted to Mn2 plus. So what is the change in oxidation state? Oxidation state of manganese in MnO4 minus is +7 and it is converted to +2. From +7 to +2 is, the difference is 5. So 5 electrons are gained because reduction is gain of electron. Then you have to balance the oxygen atom. 4 oxygen atoms in reactant. So 4H2O in product. Then you have to balance the hydrogen atoms. 4 into 2, 8 hydrogen atoms are there in the product. So 8H plus. So now you have to equate the number of electrons also. 2 electrons are there in the oxidation half reaction and 5 electrons are there in the reduction half reaction. So by cross multiplication, the oxidation half reaction is multiplied by 5 and reduction half reaction is multiplied by 2. So 5H2O2 gives 5O2 plus 10 electrons plus 10H plus. Then the reduction half reaction is 2MnO4 minus plus 16H plus 10 electrons gives 2Mn2 plus 8H2O. Now you have to add the first equation and the second equation. So let us cancel the number of electrons, 10 electrons in the product and reactant side. Now let us add this equation. First let us write 2MnO4 minus, then you see the H plus ions, 16 H plus ions in the reactant side, and in product side of the first equation you are having 10 H plus ions in the product side. So these two will be subtracted. So the excess, the remaining will be 6 H plus in the reactant side. So that 6 H plus will be written here. Plus another reactant is 5H2O2 gives, what are the products now? 5O2 plus 2Mn2 plus 8H2O. So the reactant side is the same, 2MnO4 minus plus 6H plus 5H2O2. So the product is 5O2 plus 2Mn2 plus 8H2O. So this is X dash, this is Y dash, and this is Z dash. So the product is 5O2 plus 2Mn2 plus 8H2O. And for the first equation, the product is 2Fe2 plus 2OH minus. So let us add the coefficients x plus y plus x dash plus y dash plus z dash. So it is equal to x is 2 plus y is 2 plus x dash is 5 plus y dash is 2 plus z dash is 8. So 2 plus 2 4, 4 plus 5 9, 9 plus 2 11, 11 plus 8 is 19. So the sum of coefficient is 19. So the final answer is 19. I hope you understood this question. The next question is, an example of disproportionation reaction is, so there should be both increase in oxidation state as well as decrease in oxidation state, because it should undergo both reduction and oxidation. So in first equation, MnO4 minus plus 10I minus plus 16H plus is given. So the oxidation state of manganese in MnO4 minus is plus 7, and in product Mn2 plus is present. So the oxidation state is plus 2. So from plus 7 to plus 2, decrease in oxidation state. So it is reduction. Then the oxidation state of I minus is minus 1. Oxidation state of I2 is 0. So minus 1 to 0 is increase in oxidation state. So it is oxidation. So it is a regular redox reaction, normal redox reaction, and not a disproportionation reaction. Next equation is 2NaBr plus Cl2 gives 2NaCl plus Br2. The oxidation state of Br in NaBr is minus 1, and the oxidation state of bromine in Br2 is 0. So from minus 1 to 0, increase in oxidation state, so oxidation takes place. Then oxidation state of chlorine in Cl2 is 0. Then in NaCl it is minus 1. So 0 to minus 1 is decrease in oxidation state. So it is reduction. So it is also a normal redox reaction, not a disproportionation reaction. Then option C, KMnO4 minus. KMnO4, the oxidation state of manganese is plus 7. Then K2MnO4, the oxidation state of manganese is plus 6. Then MnO2, the oxidation state of manganese is plus 4. So in both the cases, there is only decrease in oxidation state for manganese. Decrease in oxidation state. So it is reduction. Only reduction takes place for manganese. There is no oxidation for manganese. The oxidation state of oxygen is minus 2, and in the molecular oxygen it is 0. So from minus 2 to 0 is increase in oxidation state. So oxygen is oxidized, manganese undergo only reduction. So this is also a normal redox reaction, not a disproportionation reaction. So obviously option D is the correct answer. Let us see that in CuBr, the oxidation state of copper is plus 1, because bromine will have the charge of minus 1, copper will be having plus 1 oxidation state. Then in CuBr2, the oxidation state of copper is plus 2. Then elemental copper is having the oxidation state of 0. So from plus 1 to plus 2, it is oxidation, and from plus 1 to 0, decrease in oxidation state is reduction. So the same element is undergoing both oxidation and reduction. So the correct answer is option D. The next question is, in order to oxidize a mixture of 1 mole of each of FeC2O4, then Fe2C2O4 thrice, FeSO4, then Fe2SO4 thrice. So to oxidize the 4 compounds given below in acidic medium, the number of moles of KMnO4 required is. So all the 4 compounds are oxidized all together. So first, what is oxidation? Oxidation is loss of electron. So you have to calculate in total how many electrons are lost by all the 4 compounds. So you have to add that, and we know that number of electrons lost should be equal to the number of electrons gained. So we can equate with that. So let us find the oxidation of, that is the loss of electrons of the 4 compounds. So again I will explain the question. In order to oxidize a mixture, so in this mixture, what are the compounds present? FeC2O4, Fe2C2O4 thrice, FeSO4, Fe2SO4 thrice. So all these 4 compounds are present in this mixture, and 1 mole of these 4 compounds are going to oxidize all together. In same time, it is going to oxidize. So that means it is all these 4 compounds are going to lose the electrons. In acidic medium, then which is going to act as oxidizing agent? The KMnO4 is going to act as oxidizing agent. So this is the oxidizing agent. Oxidizing agent will gain the electrons, gain of electrons. It means it will undergo reduction. So the number of electrons lost by all the 4 compounds will be gained by the oxidizing agent. So we have to find how many moles of this oxidizing agent is required to gain the number of electrons lost. So let us first find the oxidation number of electrons lost. So in FeC2O4, the oxidation state of iron is +2. Why? Because oxalate will be having the charge of -2, then the metal will be having the charge of +2. Then the oxidation state of carbon in this oxalate ion is +3. So both the Fe, iron and carbon will undergo oxidation. Fe2 plus will be converted to Fe3 plus by the loss of 1 electron. Then C2O4 2 minus will be converted to CO2. So you have to balance the number of carbon atoms. So C2O4 2 minus will give 2 CO2. Then what is the difference in charge? The carbon oxidation state in C2O4 2 minus is +3. It is converted to +4. So the difference is 1 electron, but 2 atoms are involved. So the difference is 2 electrons. So 2 electrons are lost. So totally how many electrons? Number of electrons is equal to 1 electron plus 2 electron. 1 plus 2 equal to 3. 3 electrons are lost. Then in next one, Fe2C2O4 tries. So here the oxidation state of iron is +3. So only 3 units of the oxalate ion is present. So the charge of oxalate is -2. So only 2 units, 2 iron atoms are present. So already iron is present in the +3 oxidation state. Further, there is no oxidation. The oxidation state of carbon in oxalate ion is +3. So here the iron atom will not undergo oxidation. Only the oxalate ion C2O4 2 minus will undergo oxidation. It will be converted to 2 CO2 by the loss of 2 electrons. But here how many oxalate ions are involved? How many oxalate ion units are there? 3 units are there. So everything, this whole equation is multiplied by 3. So 3 C2O4 2 minus gives 6 CO2 plus 6 electrons. So the number of electrons equal to 6 electrons. So here 6 electrons are involved. Now let us go to the next one. So FeSO4 is given. Sulfate ion will be having the charge of -2. Therefore, the oxidation state of iron is +2. So iron is present in +2 oxidation state. So Fe2 plus will be converted to Fe3 plus by the loss of 1 electron. Then what is the oxidation state of sulfur? In sulfate ion, it is present in +6 oxidation state. So +6 oxidation state of sulfur is the highest oxidation state it can exhibit. So already it is present in highest oxidation state. So it means that no further oxidation takes place for sulfur. So here oxidation of iron alone takes place. So the number of electrons involved is equal to 1 electron. Then next one, Fe2SO4 tries. So 3 units of sulfate ions are present. It means the oxidation state of iron is +3. Then I told the oxidation state of sulfur in sulfate ion is +6. So already they are present in the highest oxidation state. So no further oxidation in this compound. So in this compound there is no further oxidation. So the number of electrons is equal to 0. So let us calculate the total number of electrons lost. So total number of electrons lost is, here you are having 3, 6, 1, 0. So it is 3 plus 6 plus 1 plus 0, that is equal to 3 plus 6 is 9, 9 plus 1 is 10. So 10 electrons are lost. Now let us see the reduction half reaction of KMnO4. So KMnO4 undergoes reduction. KMnO4 can be written as MnO4 minus. So already it is mentioned, it is in acidic medium. So in acidic medium, MnO4 minus is converted to Mn2 plus. Then you have to see the charge from +7 in MnO4 minus to +2 oxidation state. So the difference is 5 electrons. So 5 electrons are gained. Then you have to balance the oxygen and the hydrogen atoms. 4 oxygen atoms are present. So 4 H2O in the product side. Then 4 into 2, 8 hydrogen atoms are present in the product side. So you have to write 8 H plus in the reactant side. So here the number of electrons involved, the number of electrons gained equal to 5. But the number of electrons lost is 10. So we know that number of electrons lost is equal to number of electrons gained. So the number of electrons lost is 10. 10 is equal to number of electrons gained is 5. It means that there are some other moles of KMnO4 minus. So number of moles into 5. So you have to find the number of moles. Number of moles is equal to 10 divided by 5. So that is equal to 2. So the number of moles of KMnO4 required is option A, 2. I hope you understood this question. Next question is, how many electrons are involved in the following redox reaction? Cr2O7 2 minus plus Fe2 plus C2O4 2 minus gives Cr3 plus Fe3 plus CO2. So already it is mentioned, unbalanced equation. Oxidation state of chromium in Cr2O7 2 minus is plus 6. Then it is changed to plus 3. So it is reduction. Oxidation state of iron is plus 2. In product it is changed to plus 3. So it is oxidation. Chromium undergoes reduction, iron undergoes oxidation. Then oxidation state of carbon in C2O4 2 minus is plus 3. In product it is changed to plus 4. So here also oxidation takes place. Two species are undergoing oxidation and one species is undergoing reduction. So let us see how many electrons are involved in this reaction. First, let us write the oxidation half reaction. So Fe2 plus and C2O4 2 minus. Both of them are undergoing oxidation. They are converted into Fe3 plus and CO2. So unbalanced equation is given. So we have to balance this equation. 2 carbon atoms and 4 oxygen atoms are there in the reactant. So you have to write 2 CO2 in the product. Now oxidation is loss of electron. So how many electrons are involved? From Fe2 plus to Fe3 plus, the difference is 1 electron, and from plus 3 oxidation state of carbon in oxalate ion to plus 4 oxidation state in carbon dioxide, the difference is 1 electron, but 2 atoms are involved. So 1 into 2 equal to 2 electrons. So totally how many electrons? 1 plus 2 equal to 3 electrons are lost. Now let us see the reduction half reaction. So the reduction is Cr2O7 2 minus is converted to Cr3 plus. First you have to balance the chromium atoms. So 2 chromium atoms are present in reactant. So we are writing 2 Cr3 plus in the product. Then how many chromium atoms are there in, the oxidation state of chromium is plus 6 in reactant and in product it is plus 3. So what is the difference? The difference is 3 electrons, but the 2 atoms are involved. So 3 into 2 equal to 6 electrons. So 6 electrons are involved. So reduction is gain of electron. So you have to write plus 6 electrons. So no need to balance the oxygen and hydrogen atom because they are not given in the question itself. So the oxidation involves loss of 3 electrons, but reduction involves gain of 6 electrons. You have to equate the number of electrons. So multiplying the oxidation of reaction by 2. So 2 Fe2 plus 2 C2O4 2 minus gives 2 Fe3 plus 4 CO2 plus 6 electrons. So now the number of electrons are same. So how many electrons are involved? 6 electrons are involved. So the question is, how many electrons are involved in the following redox reaction? So the answer is option C, 6. Next question is, given X Na2HASO3 plus Y NaBrO3 plus Z HCl gives NaBr plus H3ASO4 plus NaCl. The values of X, Y and Z in the above redox reactions are respectively. So you have to balance this redox reaction. So only we will find the answer, value of X, Y and Z. So let us see the oxidation state change in the element arsenic in reactant side and product side. Then for the element bromine in the reactant and product. So the oxidation state of arsenic in NaHAsO3. So plus 1 into 2 plus oxidation state of hydrogen is also plus 1 plus the unknown element X minus 2 into 3 equal to 0. So 2 plus 1, 3. 3 plus X minus 6 equal to 0. So the value of X is plus 3. Then the oxidation state of arsenic in H3ASO4. So in reactant side it is plus 3. Now we are going to find in product. Plus 1 into 3 plus X minus 2 into 4 equal to 0. So 3 plus X minus 8 equal to 0. So the value of X is plus 5. Now let us find the oxidation state of bromine in NaBrO3. So plus 1 plus X minus 2 into 3 equal to 0. 1 plus X minus 6 equal to 0. So the value of X is plus 5. So the oxidation state of bromine in reactant is plus 5 and in product it is present in NaBr. So sodium will be having the charge of plus 1. So bromine will have the charge of minus 1. So for arsenic it is increase in oxidation state. So it is oxidation. Then for bromine, it is decrease in oxidation state. So it is reduction. So we will see the oxidation half reaction and reduction half reactions separately. So first let us see the oxidation half reaction. So Na2HAsO3 is converted to what? It is converted to H3AsO4. So the oxidation state of arsenic changes from +3 to +5. So oxidation is loss of electron. How many electrons are lost? The difference in oxidation state is 2. So 2 electrons are lost by one arsenic atom. Then we will see the reduction half reaction. So the reduction half reaction is NaBrO3 is converted to NaBr. So the oxidation state of bromine here is +5. Then in product it is -1. So what is the difference in oxidation state from +5 to -1? 6 electrons are the difference. So we know reduction is gain of electron. So 6 electrons are gained. We know that the number of electrons should be equal. So the number of electrons lost should be equal to the number of electrons gained. So how to equate that simply? So multiplying the oxidation half reaction by 3. So I will write on the top 3 Na2HAsO3 gives 3 H3AsO4 plus 6 electrons. So now the number of electrons are equal. So the coefficient of Na2HAsO3 is 3. So here you are having the coefficient of Na2HAsO3 as x, no? So the value of x is 3. But the reduction half reaction is not multiplied by any number. It means it is multiplied by 1. So the coefficient of NaBrO3 is 1. So here you are having the coefficient of NaBrO3 as y. So what is the value of y? The value of y is 1. So now you have to find the value of z. So let us write that. So you can add the two equations 1 and 2. So the value of x is 3. 3 Na2HAsO3 plus the value of y is 1. So it is just NaBrO3. Then you are having ZHCl which gives, so NaBr. The coefficient of NaBr is also 1 plus H3AsO4. H3AsO4 is having the coefficient 3. So here you have to write 3 H3AsO4. Then another compound is given NaCl. So in this oxidation and reduction half reaction, we have balanced only the element which is undergoing oxidation and the element which is undergoing reduction. That is, the arsenic atom and the bromine atoms are alone balanced. So what are the remaining elements you have to balance? So let us see that the reactant side and product side of the remaining element. First you have to see the sodium atoms. So in first compound 6 sodium atoms are there, and in second compound 1 sodium atom is there. So it is 6 plus 1. Let us keep like that. Then see the product. In first compound 1 sodium atom is there. The coefficient is fixed as 1. Why? Because in reduction half reaction itself NaBr is there. You are having the coefficient as 1. So you should not change that. So the coefficient of NaBr is 1. So 1 sodium atom. Then you are having the last compound NaCl. Here you can change the coefficient. So let us keep that as question mark. So what number you have to fill in this question mark so that the reactant and product have the same number of sodium atoms. So obviously it is 6. So in place of the question mark you are having 6. So 6 NaCl is present. Now you have to find the value of Z. So for that you have to balance the chlorine atoms. So the number of chlorine atoms present in the reactant side, we don't know that. So it is a question mark. So we can also write that as Z. Then the number of chlorine atom in product is 6. So the value of Z is also 6. So in place of Z, we can write 6HCl. So what is the value of Z? Z is having the value of 6. So that's all. The value of x is 3, value of y is 1, and value of z is 6. So the correct option is option C, 3, 1, 6. You can also cross check this by seeing the number of oxygen atom and hydrogen atoms in the reactant and the product side. So in the reactant, count the number of oxygen atoms. 3 into 3, 9 plus, here you are having 3 oxygen atoms. So 9 plus 3 is 12. 12 oxygen atoms in reactant side, and in product 3 into 4. In product also 12 atoms are there. Now you calculate the hydrogen atoms. 3 plus 6. 3 plus 6 is 9 in reactant side, and in product side 3 into 3, 9. So the number of oxygen and the hydrogen atoms are also same. So the coefficients are 3, 1 and 6. Next question is, in the reaction of oxalate with permanganate in acidic medium, the number of electrons involved in producing one molecule of CO2. So permanganate ions will act as oxidizing agent to oxidize oxalate ion to carbon dioxide. So let us see the oxidation half reaction. Already we saw this 2 or 3 times. So the oxidation of oxalate C2O4 2 minus into carbon dioxide. The oxidation state of carbon in C2O4 2 minus is plus 3. The oxidation state of carbon in CO2 is plus 4. First, you have to balance the number of carbon atoms on both sides. 2 carbon atom and 4 oxygen atoms are there. So just you have to write 2 CO2. Now, what is the difference in oxidation state? The difference is from plus 3 to plus 4, 1 electron is the difference. But how many atoms are involved? 2 atoms are involved. So 1 into 2 equal to 2 electrons are involved. And what is oxidation? Oxidation is loss of electron. So loss of electron should be written in the product side. Now let us see the reduction half reaction. So the permanganate ions oxidize the oxalate to carbon dioxide, and itself it undergoes reduction. So permanganate is MnO4 minus, and it is mentioned as acidic medium. So in acidic medium, MnO4 minus will be converted to Mn2 plus. So the oxidation state of manganese in MnO4 minus is plus 7. Then it is changed to plus 2. So what is the difference? The difference is 5 electrons. From plus 7 to plus 2, it is 5 electrons. And what is reduction? Reduction is gain of electrons. So gain of electrons should be written in the reactant side. Now we can balance the oxygen atoms. 4 oxygen atoms are present in the reactant side. So in product, you have to write 4H2O. Then you balance the hydrogen atoms. 4 into 2, 8 hydrogen atoms are present in the product side. So we have to write 8H plus in the product side. So this is the oxidation half reaction and reduction half reaction. Now we have to balance the number of electrons. So by cross multiplication, the oxidation half reaction should be multiplied by 5 and the reduction half reaction should be multiplied by 2. So only we will get the equal number of electrons. So here you will get 10 electrons. 5 into 2, 10 electrons. And here also 5 into 2, 10 electrons. So how many electrons are involved? 10 electrons are involved. So first let us cancel that and we can add the two equations, the first equation and the second equation. So while adding, you have to write the coefficient also. 2 MnO4 minus, then here you are having 5 C2O4 2 minus. So plus 5 C2O4 2 minus, then 8 into 2, 16H plus gives 5 into 2, 10 CO2 plus 2 into Mn2 plus. So 2 Mn2 plus 4 into 2, 8 H2O. So the number of electrons involved is 10. 10 electrons are involved. And how many carbon dioxide molecule is produced? 10 molecules of carbon dioxide are produced. So we can write the equation. So 10 moles of electrons are involved and they produce how many molecules of carbon dioxide? 10 molecules. 10 molecules of carbon dioxide. But in question, to produce 1 molecule of CO2 is asked. So how many moles of electrons will produce 1 molecule of CO2. So this is a direct relationship only. So 10 moles of electrons gives 10 molecules of CO2. So 1 mole of electron will give 1 molecule of CO2. So the answer is option A, 1.